Dockerfile Basics. In this section, you'll learn how to build your own images. We'll start with an introduction to the build process. Then you'll learn how to simplify your builds using base images. Next, you'll learn how to customize your image by adding files and running commands during the build process. Then you'll see how to configure your image with a default command. Finally, you'll learn how to allow connections to containers running your image. In this video, I'll give an overview of Docker images. I'll explain how Docker uses layers to build images and introduce the Dockerfile. Finally, I'll show you how to use Docker build to create your own images. Every Docker container that runs starts from an image. There are many images already available in the Docker store, which can be a great start for any project. However, every project is different, and you'll almost certainly need to build a new image for at least part of your project. Docker images are created from a series of layers. Each instruction in a Docker file creates a new layer in the image. Those layers only contain the differences between the current layer and the ones below it. For example, if an instruction creates a new file, the corresponding layer will only contain that file. The last layer is called a container layer. It is the only layer that can be modified by a running container. Layers are shared by any image on the system that needs them. Any layer that already exists on the system does not have to be re-downloaded or rebuilt. This can be a real time saver if the image you are building has a step that takes a long time to complete. That command will not have to be run again when building the image again unless one of the previous layers changes. It can also save space on the disk. For example, if two images are based on the same Ubuntu image, that layer does not need to be re-downloaded or recreated. There is only one copy of the layers from the Ubuntu image on the system. Multiple containers can use the same image. Each container gets its own read-write container layer that is separate from any other containers. The container can make any number of changes as it runs, but those changes will only be reflected in the container layer. The base image will not be affected. Once the container is removed from the system, the corresponding container layer is also deleted. Every Docker project has a file named Dockerfile. This file contains all of the instructions that Docker needs to build an image. Note that the D is capitalized and the rest of the file name is in lowercase. This file must be in the base directory of the project. Building an image is done with a Docker build command. Docker build will look for the Docker file in the given directory and execute the instructions in it. Each instruction creates a new layer in the image. Use the -t option to name the image. Docker will show each instruction as it is run and any output. Assuming the build completes successfully, the image will be available to run. If not, Docker will display an error and stop the build. If you run Docker build again, previously completed instructions will be skipped. Only instructions that have changed and any ones that follow will be run again. Let's look at how the build process works. Here I have an existing project that builds an image for the Hugo website generator. In this example, I am using the T flag to name the image Hugo. The dot at the end of the command tells Docker to look for the project in this directory. I have already built this image, so the build process goes very fast. I also have a Docker file to build the bleeding edge development release. I can specify that with the -f flag. This build fails because one of the upstream libraries fails to compile.